everyone. So we're short in time, so we're going to get right into it. Now, the previous talk was a very interesting one. We talked about models not making it to production. So that's great because that's my first slide for you. Because 87% of machine learning models today don't make it to production. So the show of hands, how many of you knew that? Great. Many smart people know. Well, there's many reasons this happens. We've seen across different engagements. It could be because teams are just focused a lot on the model architecture while they're building machine learning models. Just, what's the perfect model for me? What's the perfect architecture? Not focusing a lot on the data. There's different reasons for it. There's also just focusing on the data available today. There's focus on not focusing on production as well, just focusing on the training data available and not thinking of what happens in production. And finally, the biggest one we see is just no alignment between the ML team and the business team. And before we get into the frequently asked questions, there's just a couple of stories I want to go over. 2 stories specifically I want to go over that we've seen with some clients. The first one is an engagement. So I'm not going to go into the specifics of the use case, but the client was trying to build a model. They focused a lot on the model architecture. They built a great model that was performing very well. But one thing they did is they over-engineered that model. So what ended up happening is this model had a lot of parameters in there, a huge number of parameters. And because of that, the model needed a lot of compute power, GPU to run. As many of you know from the business side, that's not great. So while they were great in training, what happened is when they went to production, business did not accept for that model to go to production because just like the previous, relating to the previous speaker, the math didn't make sense. They had negative margins. So they ended up having to go back to the table and focus more on the data side of things, curate the data, focus on getting the right data. And what I ended up doing is they built a way simpler model. And what happened is it performed as good as the over-engineered complex model. Second story I want to talk about is more of a different industry. It was a farming use case. And that use case, the purpose of that model was to detect fruits, vegetables, and to detect the ripeness of that model. So that was an interesting one because they had a lot of data available. There's data out there. They collected all the data they needed. They ran it. Model performed great, and then they put it in production. Now, we ran great in the beginning, but one thing happened. With a show of hands, how many of you knew that black tomatoes existed? Wow, 1 person. Well, I'm with the other 9.9%. I did not know that existed. And that was the case with the machine learning team. They did not know that black tomatoes existed. So what they did is, just like any machine learning team, they went and collected the additional data for black tomatoes. They put it into the model, ran it again, put it in training, and then they put it in production. Now, with the show of hands, how many of you think that solved the problem? Wow, you guys are right. So what happened is the model was confusing tomatoes with plums. Now, there's 2 stories that points out. There's a lot of use cases like that of models not performing well in production. So let's look at why. The reason for this talk is to cover some FAQs that we get on ways to prevent this. The first FAQ we get is, where do I start with my data? So nowadays it's becoming very, very easy to collect data and store data. The infrastructure is there. It's cheap to store the data. So it's becoming very easy to have data stored, and that's where big data is coming in. So what do you do with all that data? Where do you start? We get the question of, I have all that data, do I need to train all of it? Typically what happens is ML teams think they just need to take all that data, dump it into a model, and see if it works. But typically that doesn't work, of course. And if it works, it's very expensive for the joy. What we recommend at Samba is just focus in the beginning on the business case. Understand the business case very well, align with the business team. Understand what are you trying to solve, what's the problem here. And then once you understand that, understand what data is needed for that problem. When you get to that, the next step is understand what data is not available, and then what data needs to be collected. And finally, once you do that, just identify what needs to be done what data needs to be collected in production, and what edge cases you need to account for. And once you do that, then at least you have a sense of the business idea and what data needs to be, what data is missing from your data set. You can go and collect it. It's easy to collect data sets, sometimes get synthetic data, well. So once you know, the goal is really to know what you're missing and what you have to know. So you've got the data, but now you know what data you need to use. But how do you know the data you have in training is representative of your training data? So there's 3 problems you can have in production if you don't have data that's representative. The first one is not having enough data in production, and a great use case for that is fraud detection. So credit cards, not a lot of fraud cases happen always. So you can train a great model early on, but when you go to production, how are you going to scale that? You're not going to have enough data to scale that model. The second issue you can have is data sparsity. And that is, you have enough data in production, but your data has some gaps in use cases. For example, automotive use cases. You're not going to have every single scenario or every single potential accident that could happen covered in your data. So you need to plan for that and account for that. And the third one is model bias. So an example for that is you have all the data, and the data is not sparse. You have everything you need, but the data is naturally biased. And you need to account for that. One thing we recommend to understand what is available in production versus what we have today is really having a cross-functional alignment between teams. So have your ML team sit with your business team, sit with your data management team, and all of them align on what's available today versus what's available in production. And that way your ML team will be able to understand early on what challenges they can face with your data. We're going to jump into the bias issue specifically. You identified what's available in production, you know your risks, but how do you make sure that your data is not biased just inherently? We get that question a lot. Now, why is that question important? Well, data can be biased for several reasons, and your model will get affected by this bias. So naturally, the way models work, if you have an overrepresented class, your model weights are going to adjust for the technical people here. Your model weights are going to adjust, and your model is naturally going to be biased. So let's look at an example of university admission, right? If you have an AI model that's trying to help your university predict which students are going to perform the best and assist with admissions and recommendations. Well, if you have a university that has a lot of admissions from a local high school in the town, just naturally because everyone from that high school prefers to go to this university because they don't want to pay for accommodation. So what's going to happen now is your model is going to see a lot of that data, and assuming obviously that a big chunk of these high school graduates have done well in the university, your model is going to automatically start thinking or being biased towards graduates from that high school because it just saw a lot of it. Your model is being incentivized to perform better on the prediction, so it's just going to naturally be biased towards these high school graduates. Well, that's not really the story. So that's why it's really important. But how do you solve for that? Well, the biggest, maybe obvious, maybe not obvious one is just assume your data is biased. Always assume that it's biased. Understand what bias could arise and test for that bias. Always. The second one that we recommend and we offer solutions for is curating your data. So some offers some curation solutions to allow you to detect model bias early on. So you put all of your data in, you look at your embeddings, and you're able to visually and even computationally just see what bias do you have in your model, detect that early on, and account for that. Another FAQ we get is, which parts of my training data should I get annotated first? So companies we work with typically have tens and hundreds of millions of data sets, 2D and 3D images and videos. And that can be overwhelming. You'd think that you want to annotate everything. Well, the good story is you don't have to annotate everything. You just need to select the data that's good for your model. And then there's 3 types of data you're going to face. Because not all data is important for your model. The first one is data that's very good for your model, data that represents new use cases, and data that has just like a black car that was not seen before and previously for the model. So that's good data. There's the data that's not good for your model, which an obvious one is repetitive data. If you have a video with a lot of frames, you don't need all the frames because that's repetitive. But the third one, which is most important, is data that is bad for your model. And that could be because there's just natural bias in data, which we just talked about. And that type of data you definitely want to get rid of. So you want to be able to identify the first one, which is the type of data that is going to be good for your model. And the thing is, machine learning teams know that today. Many of them know that, some of them don't. But the challenge is the tools are not available for that. So far what teams have been doing is manually curating their data to select the right data sets for them. But how do you scale that? If you're talking about tens and hundreds of millions, well, you need tools for that. Some machine learning teams rely on scripts that look at simple metrics of images and videos, but that doesn't work for everything, and it's also not scalable. So one thing we offer them is something we call curate, which is a curation tool that allows them to curate their data set automatically. And what that is essentially, it's an ML system that is allowing you to curate your ML model, which is an interesting concept, using ML to train ML. So with ML, there's a trend right now, that's an emerging set of tools that are coming up that are helping ML teams curate their data automatically, and that is the way to scale and understand what data you need to annotate first. The tool allows you to skip the irrelevant frames, account for bias by having a good balanced data set, and just focusing on the important data. So you've done that. Your model is performing great. You have a lot of data sets. You have a huge pool of data. But then there's some edge cases or special cases where your model is not doing great. An example could be if your model is trying to detect vehicles. Your model might be doing great at detecting vehicles, but not detecting ambulance vehicles in the morning because they look different, or at night when the lights are shining. So what do you do for that? That's one of the common cases. This can be solved as well with a solution called similarity search, and that is also trending today in curation tools. What you can do is implement similarity search where you take the data that's not working well in your model. So you take all, you know that your model is not detecting images as well. You have maybe 500 images of that only, 250 a night, 250 a day. You take that and you do a similarity search. So you put it through the curation tool, and you find hundreds and thousands of similar images. If it exists in the data set, it automatically find similar images for you. And then you run that back into your model. The advantage here is you saved a lot of time navigating your millions and billions sometimes of data sets, and are able to train your model faster on these special cases. Another FAQ we get is, what kind of labels do I need? And what is the quality I need? Do I need to aim for 100%, 90%? What's the number here? Well, let's go back a bit to the university question. So if we were to identify the gender of the applicants, is that really relevant? No. In fact, it might infer bias in your data, in your model. So that's not important to capture. If you look at an autonomous vehicle use case, do you really need to understand if there's an adult or a child out there? Or are both the same for you? Do you need to understand if you have a stroller versus a pedestrian? Your goal is just not to hit both of them, so why does it matter? I'm not saying ignore them for all cases, but I'm just saying account for that. Do you really need to identify the difference? And in the example here, well, do you really need to go as tight as annotating every single point around your motorcycle or your vehicle? Can you go a bit looser? Or can you even put a bounding box? Well, in many cases, if your goal is to avoid that motorcycle, why do you need to know how accurately the mirror is designed? You just need to avoid that whole box, or that whole cuboid in 3D. So start simple is what we recommend. Start with simple use cases, simple annotations. Don't go all in. We get customers asking us for, hey, can I do semantic segmentation right away from the beginning? Just start with bounding boxes, cuboids. If you think that that's what you need, I mean, if you need to do a segmentation right away, go all for it. But start simple. Start with small data. And when you know what type of annotation you need and the quality you need, do you need 95%? Do you need 99? Are you okay if the bounding box eats part of the mirror, or maybe has a bigger chunk of the conference here included in the bounding box? Account for all of these, test all of these. And then when you know what works for you, then scale your model. Come to an annotator or to an annotation company and say, well, now I know the type of quality I need. I need hundreds of thousands of this type of annotation. But don't just start to annotate 1,000 annotations without knowing what kind of quality works for you, or what kind of accuracy is important for you. Another question we get is, how do I capture edge cases? This is an interesting one because you've done everything you need, you've planned well for your model, and you've trained it, you got the right quality, but you put it in production and then you get an edge case. Like let's say in this case, the self-checkout use case. It's Halloween and then you get a teddy bear walking into your store shopping for chocolate and chips. Like, you couldn't have accounted for that, definitely. And we definitely don't recommend accounting for every single edge case because you're never going to capture them all. Who would have thought teddy bear would walk into a store buying stuff? What we recommend instead is just put in place a plan. Whenever it's, know that it's going to happen. And put in place a plan to quickly act upon it when it happens. So if the use case comes up, how do you start? How do you take that data, send it back to your annotators? What do you do with it? Put a process in place, put a budget aside for it, and just know that it's going to happen. And then when it starts happening, you need to build a very tight feedback loop with your annotators, whoever they are. Yeah, your SMEs that understand these edge cases, your subject matter experts, need to have a strong relationship with your annotators and allow them to become experts in these edge cases. And slowly your annotators will start capturing these whenever they're validating your model or annotating new data. They'll automatically start accounting for these in the training data. One other FAQ we get is, how do I measure my model performance? And how do I make sure that my model is performing great in production and that there's no drifting in my data? And we don't get that question a lot. Not a lot of teams are thinking of that. A lot of people overlook this problem and think that once you go put your model in production, it's going to perform great. Well, it won't. We can guarantee that it won't stay performing great. Your model will always deteriorate because it's always going to see new data and change the data. And here's a simple use case, for example. If you're looking at the luggage use case, you might think, well, luggage is luggage. There's thousands of types, but once I collect them all, I detect all the edge cases, I'm all good. Production, I'm not going to have any issues. Well, fashion trends change. So what if you start seeing new designs? Louis Vuitton comes up with new complex design that no one has seen. It's going to happen. There's fashion trends that change. So your model is going to start slowly deteriorating, and your performance is going to start decreasing. If you don't account for that, and there's two ways to account for that and really detect model drift. Just first of all, know that it's going to happen for sure, and you have to communicate to business that it's going to happen, and then plan for it. So how do you do it? The first way is you need to monitor it. You need to have a process in place where all of your data being seen by your model is being compared to your training data. And that can be done by a curation tool. Sam helps clients with that today. And looking at production data, comparing it to the training data, look at the embedding, see if there's a huge difference in the embedding space between your production data and the training data. And if there is, you know that your model will start drifting because it's seeing new types of data. You take that out, you send it for annotation, you train your data. The other part is you have to always take a sample of your production data and validate them. So I'll think, we're not going to define the percentage, it could be 1%, 10%, 5%, but always take a percentage of your production data that you think is working well and give it to a set of annotators. Let them validate, and ideally, it would be the same annotators that were training your initial training data. Because they're the experts. They know, they're subject matter experts in your data now. They know best how your data should be annotated, and if they train your model, they definitely know how your model should perform from an output perspective. So send them the data, a sample of it, let them validate it, and tell you if your model is actually working great. And if it's not, then you can use that data and use that data and just annotate it. We're at time, so I'll just end up with one for you is, if this talk got you to think, who should I trust with my training data? I'm not going to head through that now, but we have a booth at Salvage Dangerous. You can head to our team and talk.